students. Great to have you back. I hope you had a great holiday. Now today we're discussing integration of sine ax plus b, or cosine in the form of cosine ax plus b, or sec squared ax plus b. And you will note that this is something that you should be familiar with. Remember, integration is just the opposite process of differentiation, and we've learned to differentiate these functions. So when we differentiated sine ax plus b, that gave us a cosine ax plus b. So that leads us to this rule here. When we are going to integrate a cosine function, we're going to get back to a sine function. So this is how it works. Cosine ax plus b, when we integrate that, that will get us 1 over a sine ax plus b, and then of course plus the constant, or plus c. And when we differentiated cosine ax plus b, we got negative a sine bracket ax plus b, and when we therefore integrate a sine function, we're going to get back to a cosine function. So sine ax plus b dx, if we integrate that, we'll get minus 1 over a cosine ax plus b plus a constant. And remember with tan, when you differentiated tan, you got a sec squared. So this leads us to this rule here. When you are integrating a sec squared function, you're going to get back to a tan. I'm pretty sure these are in your function sheet, but it really pays to be quite familiar with them, as it'll make your life easier when you're getting into exam questions. Okay, well, let's try a few. We're going to integrate cosine pi minus x. So what I'm going to do first is I'm going to look at my rule here. So if I'm integrating a cosine function, I need to go 1 over a. So a in this case is my minus 1, the coefficient of x, right? Minus 1, which of course 1 over minus 1 is minus 1, into, and then it will be sine pi minus x plus c. I'm just going to get rid of that bracket that I accidentally put in the wrong place. So simply this will be minus 1 sine pi over x, pi minus x plus c, and we can get rid of the minus 1 and just have a minus sign. So that's our first one, fairly facile. Let's move on to the second one. We're integrating minus half sine half x. So I'll do this one in green. What does this equal? Well, we're integrating this here. You note we've got a coefficient here, so I'm going to go minus 1/2 times. Now I'm going to start my integration. Sine half x. So I'm going to take the a in this case is this half, so I'm going to take that and I'm going to put it over 1 over it. So what I've done here is this, minus 1 over 1/2, which of course is just going to be minus 2. Then I'm going to have that multiplied by cosine 1/2 x plus c. This here, I've got a minus times minus, so that's going to be a positive. Half times 1 over 1/2, which is 2, so it's going to be just 1. So our final answer will be cosine half x plus c. Alright, another one. This one here, we've got a range here, so I'm going to be using this rule here because I've got a sec squared x. So I'm going to put my square brackets. Okay, it's going to be 1 over a. In this case, a is the 3, the coefficient of x. So I'm going to go 1/3, and then I'm going to write tan, and then I'm going to write 3x plus pi over 12, and then at the end of the brackets I'm going to have my limits. we're dealing with a definite integral here. And what that will end up being is 1/3 tan, what's that, 3 pi over 12, which is pi over 4 plus pi over 12. And then from that we're going to subtract 1/3 tan, 3 times 0 is 0, so it's just going to be 10 pi over 12. And I'm just going to chuck that in my calculator now. Okay. Okay. So I'm getting this answer on my calculator, minus 2 plus 2 square root 3 all over 3, and this can be given to three significant figures as 0.488. Alright, we'll now move on to a word problem. This is question 6. And for this one, we are told that we've got to find the area bounded by the graph of y is equal to sec squared 2x plus pi over 2, the x-axis, and the lines x equals pi over 4 and x equals pi over 3. Well, area, we're going to use integration, so I'm going to integrate between pi over 3 and pi over 4, so like a definite integral here. Sec squared 2x plus pi over 2. Okay, that's what I'm going to do. So what do I get here? Well, I'm going to have my square brackets. I'm going to use my rule. So this is going to become 1/2 tan 2x plus pi over 2. And then at the end, I'm going to put in pi over 3 and pi over 4. And now let's chuck this into our calculator. So we're going to have 0.5 tan. Oh, make sure you set to radians, by the way, for this. 2 pi over 3 plus pi over 2. And I get for my first one square root 3 over 6, and then we subtract our second one, which is a 1/2 tan pi over 2, or pi, which is 0. So our final answer for this one is going to be square root 3 over 6, and that is equal to 0.289 to three significant figures. So I feel like this is probably a fairly easy exercise. The trick will be remembering those formula, or being able to work with them pretty quickly rather than having to struggle to think what you have to do. So have a practice. Let me know if you're having any trouble with any of these.